polynomial equations. Our objectives are going to be to factor polynomials, solve polynomial equations by factoring. The vocabulary we're going to learn here is prime polynomial and quadratic form. Now, so far we've learned to factor quadratics. Pretty simple. So we're going to learn a few different ways with bigger polynomials with higher degrees than 2. For instance, on page 342, you look at the key concepts, and we have the sum and difference of cubes. So basically, we said if we have a sum of cubes, you'll have or difference of two squares, we've learned. A squared minus b squared, we've learned how to factor that. That's simply a plus b times a minus b. Now, the two new ones we're learning are sum of two cubes, which means you have a degree of 3. They're perfect cubes, and difference of 2 cubes. So sum is just addition. So what you do is you take this cube root of a, whatever sign, whether it's plus or minus, cube root of b, times a square, so that would be the cube root of a, and you square it, and you take the opposite sign, which is minus, and then the product of ab, plus b squared. You do the same thing for the difference of cubes, except for the only difference is the signs, but you factor them the exact same way. All right, so if a polynomial is not factorable, we call it a prime polynomial. So let's just look at example 1a. And it asks us to look at the problem is going to be 16x to the 4th plus 54x y cubed. It says factor each polynomial. If the polynomial cannot be factored, write cannot be factored or write that it's prime. Well, we don't have, this is a perfect square, but this is not a perfect square. Y cubed is a perfect cube, but x and 16 and x to the 4th, these aren't perfect cubes, so we can't use those special rules. But we can look, do they have a GCF? Yes, they do. What is that GCF? It's 2x. So we are left with 8x squared plus, what is 54? 27 y cubed. Now there's nothing that can be factored here, is there? Oh, actually, this is cubed. So don't I have the sum of perfect cubes? So now I take, this is going to be a, so we're going to let a equal 2x, because the cube root of this term. This is going to be your b term. I always identify that first. Cube root of 27 is 3. Cube root of cube is y. So I have 2x times, remember it's a plus b, which we're going to put 2x plus 3y, times a squared minus ab plus b squared. What is a squared? 4x squared minus 6xy plus 9y squared. And there you go. That's your answer. That's as far as you can go. But you need to make sure and take your original equation, identify what a term is and b term, and take the cube root. Then it makes it easier to plug it into this formula. Okay, so now if you look on page 343, there's a table, and it shows you, it summarizes the most common factoring techniques used with polynomial. So whenever you factor polynomials, you always look for a common factor first, then determine whether the resulting polynomial factors can be factored again using one or more methods. So any number, you always look for a greatest common factor. If you have two terms, you look for difference of two squares, sum of two cubes, difference of two cubes. If you have three terms, you look for a perfect square trinomial, and you look for general trinomials. And 4 or more, you're going to have to do grouping. This is when it gets a little more complicated. So look at example 2. It says factor each if possible. If not, say write prime. So our problem is 8ax plus 4bx plus 4cx plus 6ay plus 3by plus 3cy. Now, they don't all have a GCF. Can't do that. But if I look at this term, this term, this term, they all have x. So I'm going to group those together, and I'm going to group these together. I'm going to factor out an x, and I'm left with 8a. Actually, I can factor out a 4. So I'm left with 2a plus b plus c. Here, I can factor out a 3y. So I'm left with 2a plus b plus c. So now I went from 6 terms to 2 terms by grouping and factoring out. Now I can look, they have a common factor, don't they? Right here. So I'm going to take out a 2a plus b plus c. I'm factoring out, right? Divide it by that. What am I left with? 4x plus 3y. So remember, when you're factoring out, you're dividing by that factor. All right, so that's all we're doing. Let's look at number B. And that problem is 20fy minus 16fz plus 15gy plus 8hz minus 10hy minus 12gz. Are there any common factors? No, they're not, but we can group 20fy and 15gy and 10hy, right? So 20, you have to use the commutative property here to rearrange, and then the associate property. And then what do I have left? Then I have plus negative 16fz plus 8hz minus 12gz. They have a common factor of y and of 5, and I'm left with 4f plus 3g minus 2h. Here I'm going to factor out a 4, a negative 4z, and I'm left with 4f minus 2h plus 3g. I just rearranged this, but these two are the same, so now I've got a common factor that I can factor out. So then I'm left with 5y minus 4z. All right, that's all for that one. Now, let's look at example 3 on the next page where you've got multiples. And let's look at this one. So we have x to the 6 minus y to the 6. We'll have two terms. Aren't these perfect cubes? You simply take, is this a multiple of 3? Yes, it is. So a is going to be the cube root of that, which is x squared. B is going to be y squared. So it's going to be x squared minus y squared times a squared, which would be x to the 4th, plus, change the sign, ab, which is x squared, y squared, plus y to the 4th. Now, what do I have left here? Oh, sorry, I did this backwards. First I have a difference of perfect squares. So I would do x to the 3rd minus y to the 3rd times x to the 3rd plus y to the 3rd. So ignore this. We have a difference of perfect squares because it's an even power. We just divide by 2. Now we have difference of cubes, so it would be x minus y times x squared plus xy plus y squared. You have the sum of perfect cubes, so it's x plus y times x squared minus xy plus y squared. And there you go. There is your answer. All right. And we'll look later on how to use word problems. Now, in some cases, a polynomial can be written in a special form called au squared plus bu plus c, where u represents some form of the x. And we call this form a quadratic term. For instance, if we had x to the fourth plus 12x squared plus 32, we could rewrite this to say x squared raised to the square plus 12x squared plus 32, or we could say u squared plus 12u plus 32 if we let u equal x squared in this case. Then it makes it easier to solve, and then we can go back and substitute x squared for u at the very end. Let's look at an example of that. So if we have the expression 150 into the 8 plus 40 into the 4 minus 15. This is kind of a hard concept, so we'll do several of these in class. So the first thing they want us to do is they want us to write it in quadratic form. So I look at these two. 5 squared is 25, and 25 times 6 is 150. So I can rewrite this to say 6 times 5 into the fourth square. Because remember, use the power rule, not the product. That would be n to the 8th, 5 squared, and we know 25 times 6 is 150. Plus, if I want to do this, I can do 8 times 5 n squared raised to the second power. Into the fourth, sorry. Raised to the first power. Minus 15. What we're looking for is in parentheses. We want this to be the same thing. So we're going to let u equal 5 into the fourth. Then we rewrite it, say 6u squared plus 8u minus 15. Now, it makes it much easier for us to solve this equation or to factor it. Okay. Let's do another one. We'll come back to actually doing some. Y to the 8th plus 12y cubed plus 8. So we see we have a y cubed. We always look at the linear term. And we can rewrite this to say y what? Cube. Can we do y cubed? No, because we do y cubed squared, that gives us y to the 6th. So this one can't be written in quadratic term form. Sometimes it can and sometimes it can't. So let's look at another one. We're actually going to solve it. So 18x to the 4th minus 21x squared plus 3 equals 0. So we have x squared here. So we know we can do x squared here. We can raise that to the square, right? That equals x to the 4th. Here you have what? 7 and 3. And here, is there anything that we can take out here? Let's look at it. We can say 3 square is 9. 9 times what is 18? It's 2. So remember, this still has to equal when you simplify it to the original term. Then we can say minus 7 times 3x squared plus 3 equals 0. So we said let u equal 3x squared. So 2u squared minus 7u plus 3 equals 0. Now we can actually factor this to say, and that's a whole nother, we'll talk more about factoring in class, u minus 3 equals 0. Now we just set them equal to 0. This is u equal 1/2, u equal 3. Now we go back and replace u with 3x squared. So we say 3x squared equal 1/2. And we solve, we say x squared equal 1/6. Use the square root property. X equal plus or minus 1 over square root of 6, which we have to rationalize. And we get equal plus or minus square root of 6 over 6. And then we do the same thing for here. We say 3x squared equal 3, x squared equal 1, x equal plus or minus 1. So do you see we have 4 solutions here? We have 1, -1, square root of 6 over 6 and negative square root of 6 over 6. So this is why we try and put it in quadratic form, and that way this will help us to better solve. All right? So do your problem that was assigned, and we'll see you in class. Look at the assignment sheet.